Hello and welcome. In today's video, we are discussing about Python hash tables. So, what is a hash table? Hash table is another data structure available in Python for fast operations like insert, delete, and add methods. So, it is a data structure to work for faster insert, delete, add operations. Comparing to linked lists or arrays. In linked list, finding a person called Anna takes time because we would have to go from first node to the target. Until we reach the target, we have to traverse through all elements. And then finding the same Anna using list or array in Python could be fast comparing to linked list, but it is also time consuming if we have to find without having index available. So it also takes time to traverse from first element to the target index position. So with a hash table, finding Anna is done really fast because there is a way to go directly to where Anna is stored using something called hash function. So let's see programmatically how to build hash table from scratch and even write a hash function to it and insert element, look up for element and deal with all handling collisions in hash table. So the basic steps to create hash table is create empty list. It can be dict, it can be set also, not only list. You have to create a hash function. You have to insert element using the hash function. Number 4 is look up element using the hash function. And fifth is handling collisions. Let's start creating empty list. How do we create? We are creating hash table, so I'll name it hash table. We'll create a empty list first. So empty list should have values. I'll create some 10 numbers with empty value as none. This has 10 nones, which is 10 null values. And step 2 is what? Creating a hash function. So now let's discuss what is a hash function of a table. We want to store a name directly into its right place in the array, and this is where the hash function comes in. Hash function can be made in many ways. It is up to the programmer of the hash table. A common way is to find a way to convert the value into a number. So based on the number, we can find the value in a quicker way. So in our example, we will use Unicode, number of each character, summarize them and do a modulo 10 operation to get index numbers 0 to 9. So Unicode is nothing but ASCII values of the character. If Anna is the name, For A, it is 65, B, it is 66, until Z, it goes on increasing Unicode. So let's write hash function definition. Hash function provide the value Anna, and let's do sum equal to 0 for each character. What we will do, alphabet in value, sum has to be increased or added up with Unicode number, which is nothing but ORD function of, we will put alpha. So the alphabets Unicode will be summed up into sum. And now what we are going to do, return sum modulo 10. If it is 65, 65 modulo 10 becomes 6. That is the value for A. If it is Anna, it will sum up all Unicode numbers and then modulo 10 is what it gives as hash function value. So if I provide Anna to this method, what it has to return, first what I have to do after this, we have to call the hash function print Anna has hash code hash function so Anna has hash code hash function of Anna. If you print it, it has to traverse through this function and return the sum for modulo 10. So let's see, for Anna the value becomes Anna, sum is 0 first time. For alphabet in value means first from Anna, first letter A will be fetched as alphabet. Sum plus is equal to order of alphabet, which is 65 for A. 0 plus 65. Here it becomes 65, and again it fetches next alphabet, which is nothing but N. For N it is 110, and A again, but this time it is small a, which is 97. So let's do the sum of these and then do a percentile modulo. So we have traversed to each alphabet of value. 65 plus 110 plus 97 becomes 272, and 272 modulo 10 is nothing but so percentile 10 of 272 becomes the remainder 2. So this value has to become, Anna has a hash code of 2 is the output here. So that is how we write a hash function, and the next step in implementation of hash table is nothing but inserting element. So for that we have hash code for Anna as 2, the number returned by hash function. 2 is a hash code for the string Anna. So before diving into inserting element, let's discuss what is Unicode number. Everything in our computers are stored as numbers, and Unicode number is a unique number that exists for every character. For example, capital 8 is 97, capital 8 is 65, and small 8 is 97. You can browse through more Unicode characters for each alphabet. And modulo, a modulo is an operation divides a number with another number and gives us the resulting remainder. For 272, which is 2, so the hash code for Anna becomes 2. So now let's start writing insertion of element to hash table. According to our hash function, Anna should be stored at index number 2. Let's create a function that add items to our hash table. So definition, add name is the parameter, which is Anna, index equal to hash function we have written before of name Anna. So this is the index. My, we will call our hash table of index, which is hash code equal to name. So we have added to the list based on hash code as index with the value name Anna. So let's now try to call the method Anna. So it adds Anna at index 2, which is hash code, print hash table. It prints the added Anna value with index 2. If you even print, it will print index 2 and the value as Anna. You can try running the code using any editor or even online editors. You can run and see the output for this insertion, whether it works or it doesn't work. Let's move to next session, which is lookup. So currently we just added one element. So let's add more elements. Add Jones. So it will add to hash table again and add Lisa based on the hash code fetched for it. It will add it over there. So for Jones, it becomes 2 again. So it replaces the Anna, and Lisa it becomes 3. So it inserts at position 4. For Jones, it becomes 1. So it inserts at position 1. And let's try with another name, which is add Bob. For Bob, it becomes 5. So it inserts at position 6. And add Siri. It inserts at position 8. Add Pete. It inserts at 9. So the remaining empties will remain empties. So now we have 10 elements, among which few elements that we have added. Like above, we have added almost 6 elements, remaining 4 are empties. Let's try to write lookup function for a name. Now let's find Pete. Pete is at which position? As we have seen before, Pete is inserted at position number 9. So let's write a function for lookup name, which is Pete index hash function name, it which is 9, and return hash table of index equal to name, means whether it is available or not, it returns true. If it is available at that particular hash code, if it is not available, it returns false. So that's about lookup function for hash table. So when we are finding through hash function hash code, it directly goes and finds Pete at position 9, which is time complexity O of 1, which is very fast with the use of hash code. So that is the main reason why we use hash table compared to linked list and arrays. And fifth step, handling collisions. So what is handling collisions? Let's also add steward to our hash table. We give steward to our hash function, which returns 3, meaning steward should be stored at index 3. Trying to store steward in index 3 creates what is called a collision, because Lisa is already stored at index 3. If you go back to the existing values, if you go back to that, so it has the values like hash table. Let me take small hash table equal to, it has inserted Anna at first position, second position, no, it has inserted Anna here. So this is the existing function. So now if you try to insert another value which is steward that has index 3, what we have at index 3 is Lisa, so that is a collision. To fix the collision, we can make room for more elements in the same bucket, solving the collision problem in a way called chaining, and means giving room for more elements in the same bucket. Start by creating a new list with the same size as the original list but with empty buckets. So to solve collision, we do chaining. For that, hash table now has to be defined as buckets. So let me show you how do we define buckets. So in place of empties, we are giving empty list. So this is how chaining empty list, empty bucket. Prior to this empty list we have created, now empty buckets. And now we have to modify the existing add method by definition add name index equal to hash function of name, hash table of index dot append of name. So at the index we are just appending to that list. So now if you do the same thing and list in the same position, Lisa and Stuart will be shown as a list. So let's see how it is. Hash table becomes with this, if you add the same elements there like before we have done here. Along with Stuart, let's see, we have this, we are adding Stuart. Now this becomes actually this becomes empty and this is list. Again this is a list. This is also a list and this is a list and list of single element, empty list, list single element, list single element and empty list. So now after adding new elements to it will have to append into the list with index, same index, which is 3. It will have to add to it there because we are appending. So this will be the new updated add method and how it is working to solve the collision with chaining. Alright. So after implementing each bucket as a list, Stuart can also be stored in index 3 as a list of 2 names. And our hash set now looks like this. This is the final hash set with the Stuart at the same position as Lisa. So now searching for Stuart takes a little bit longer than the previous add method because we also find Lisa in the same bucket but still much faster than searching the entire hash table using hash code. So let's discuss now the uses of hash tables. Hash tables are great for checking if something is a collection, like finding a book in a library, storing unique items and quickly finding them, like storing phone numbers, connecting values, like keys, like linking names to a phone number. The most important reason why hash tables are great for these things is that hash tables are very fast compared to Python arrays or Python linked list, especially for huge data sets. Arrays and linked lists have time complexity O of n for search and delete, while hash tables have just O of 1 on average. Hash tables has elements stored in storage containers called buckets. A hash function takes the key of an element to generate a hash code. The hash code says what bucket the element belongs to. So now we can go directly to that hash table element to modify it or delete it or just check if it exists. A collision happens when two hash table elements have the same hash code because that means they belong to the same bucket. Collision can be solved by chaining by using lists to allow more than one element in the same bucket. So that's all about hash tables. So for interview purpose, let's quickly look into the basic level questions. What is a hash table? Hash table is a data structure that stores key value pairs. In Python, the built-in dict type is implemented using a hash table. And then other question, how does a hash table work? It uses hash function to convert keys into indexes of an array where the associated value is stored. Collisions are handled using techniques like chaining, or there is another method called open addressing. If you would like me to add example for open addressing, please comment. I'll add the required section. I'm happy to help. So other question will be like what is the hash function, which is basic. So it is nothing but a hash code for each bucket. How do you create hash table in Python? Just by creating a new dictionary or list or set. What is the time complexity for basic hash table operation? Insertion, it is average of O of 1, deletion O of 1 and lookup O of 1. However, worst case, it can be O of n due to collisions. And we will dive into questions asked for experienced folks. What happens when two keys have the same hash value? So what happens? It is called collision and it can be addressed using chaining. And more questions. How do you make a custom object hashable in Python? How do you make it? We can make it using implementation like underscore underscore hash underscore underscore and underscore underscore eq underscore underscore methods in the class. And what is the difference between dict and collections default dict? Default dict provides a default value for a key that does not exist, avoiding key error. So that is the major difference. How does Python ensure hash table resizing? Python automatically resizes the hash table when the load factor exceeds a threshold, usually around 2 by 3. This helps maintain constant time operations. Let's see few advanced level questions also, like what is the load factor in a hash table? The load factor is the ratio of number of entries to the number of buckets. A high load factor increases collision chances. And the next question is explain how hash randomization in Python. So when we discuss about randomization in Python, since 3.3 Python version, hash randomization is used to prevent hash collision attacks by using random seeds affecting the order of keys in dictionaries. What is the difference between is and double equal to when comparing keys in hash table? Double equal to checks for value equality and is checks for object identity like is class, is string, is float, is integer, etc. Python dictionaries use equal for key comparisons. Can a hash table maintain insertion order in Python? Yes, hash table maintain insertion order in Python since the version Python 3.7. Dictionaries preserve insertion order as an official language feature. And how would you implement a hash table from scratch in Python is what we already have seen with the example. Just go back to that particular description to understand. So that's all about hash table in Python. If you have more doubts about any functionality like hash code generation or chaining or furthermore into other techniques to handle collisions, please comment. I am happy to help. That's it for today. Thank you for watching.